algebra from the subject database management system. So what is this relational algebra? Relational algebra is nothing but a set of procedural query language. Now what is this procedural query language? So it follows some procedure and writes a query. So it's basically that, in order to retrieve a particular data from the database. So it takes some input and produces some output. Okay, we don't know how it does the processing and all. Input, we provide the input and then we get the output. So in relational algebra there are various operations known as fundamental operations, then additional operations, then extended relational algebra operations. Now in today's video I will cover only fundamental operations, otherwise it will go on a too lengthy way. So in my next video I will do additional operation and extended relational algebra operation. Now let's start with fundamental operation. In fundamental operation there are various operations like select, project, composition, union, set difference, Cartesian product and rename. So one by one we will see. Now select, as the name suggests, it selects some rows from the table which satisfies a given condition. Okay, so the syntax is, first of all the select operation is denoted by sigma, a Greek letter, sigma, then the condition and then the table name. So suppose I want to select the row which consists of a name PQR. Okay, so I will write sigma, in the subscript I will write name equal to PQR and then the table name. So this is nothing but a selection operation. It will select the whole row. Now suppose if I want to select only particular columns, the whole column, not a particular row, I am telling about the whole columns with their whole data. Okay, so this can be done with the help of projection operation. Suppose I want to select or take the two columns, like first is customer ID and the second is name. So I will write a query known as this. First of all, the projection operation is denoted by pi. Okay, so I will write the query as pi. This is the column names that I want to retrieve from the customer table. So customer ID, name and then the table name. Now the third is composition. So composition is nothing but a combination of selection and projection operation. Now suppose I want to join the projection operation as well as the this selection operation. So I can now like I want to retrieve data as I want to access the address of the customer PQR. Okay, so this can only the address, I want only the address of a particular customer named PQR. So this I can write it as composition. I will combine these two as, first of all I will write pi name, sigma name equal to PQR from the customer table, right, from the customer table. But I want to access only the address of the customer name PQR. So this can be done by putting here pi. What I want only the address. So now by writing this query, I will get the address of the customer name PQR from the customer table. Done. This is all about composition, combination of the projection, and the selection operation is known as the composition operation. Then the fourth is union. Okay, so now let's take an example, like I am having a depositor table, okay, who have an account. The customer who have an account will be displayed in this depositor table, which consists of customer name, account number, and I am having a borrower table which consists of the customers who have taken the loan. Okay, first customer name and then loan number. Now I want to fire a query, or I want to find the names of all the bank customers who have either an account or loan, or they have both. What I'm saying, I want to find the names of customers who have either account or loan, or I'm saying or loan, or both. So it's like this: depositor, borrower, they have something in common, so I want everything from this, either this or both. Okay, so this can be done with the help of, now I want only the customer names, so I will write pi cust name from the depositor, and I want name from borrower table as well, right? Pi cust name borrower. So if I want the data of these, account number or loan or both, so this can be done with the operator known as union. If I write, all the data will become like who have account or loan or both, all the customer name will be. So you can see here we are using two tables, depositor, borrower, in order to perform a union operation. So we can say that it is a binary operation. Okay, and here in composition, in projection, or in selection, we used only one table, that is customer. So we can say that projection, selection and composition are all unary operations, right? So they are unary operation which works on only one table. But here union works on two tables. In order to get it into action, the union operation, we need two tables or more than two tables, right? So for that reason it is known as a binary operation. Okay, so the next operation is the set difference. Set difference. Now again, the set difference operation is a binary operation. Binary. Okay, and denoted by a minus symbol. So it will find the rows which are in one relation but not in the other. Suppose I did R minus S. So it will select the rows only from R table and not S table. Okay. So suppose I want to find all the customers who have account but not a loan. So as it is a binary relation, we need to have two tables, right? So I will write by cust name depositor by cust name borrower. Now I want to omit the customer names who have a loan. I don't want that to be in my query, right? So I will put just a minus sign in between these two operations. So I will get the customers who have account. They are having account. In depositor table we have the customer who have an account, and here who have loan. So I've skipped this. I don't want this, so I will remove this. Okay, so this is set difference operation. Now the next operation is sixth, which is Cartesian product, and it is denoted by a cross. Again, it is a binary operation, so we need two tables, right? Now it allows us to combine the information from any two tables, and it is written as R1 into R2. Now what is this R1? This is one table, this is another table. We are combining it to form another table. So this is nothing but a Cartesian product. Now let's take an example. Now suppose in R1 table I am having two columns. R1 table में I am having two columns C1, C2. Suppose the data is 1A, 2B. And in R2 table I am having two columns C3, C4. 3x, 4y, 5z. Okay. Now I want to combine these two. So this can be done with the help of this, that is with the help of Cartesian product R1 into R2. I will get the data as C1, C2, C3, C4. 1A, this row with this row again with the second row, and then the third row. 3x, 1a, 4y, 1a, 5z. Then again the second row, 2b with 3x, 2b with 4y, and 2b with 5z. So in this way we will get the Cartesian product. Okay. Now the next operation is rename operation. So this rename operation is a unary operation. So we have seen the composition, selection and the projection operation to be unary, and another one is rename operation, which is a unary operation. Okay. The rename operation is denoted by row. Okay. So suppose now we have made a new table. Okay, or we are finding some data, but we want to rename the columns or rename the table name. Okay, so suppose there is a borrower table and we are retrieving some data. So we will write row, then new table name, suppose BO, then C name, we are having customer name, right? Then we are having loan number, so LO number suppose I am writing, and the name of the table is borrower. It's like I am retrieving some data and a new table is created, right? In Cartesian product also we are performing R1 into R2 and a new table is created. So suppose I don't want the previous names, I want some another name. Okay, so I'm renaming the name. Okay, so these are the renamed names of the columns and the new table name, that is BO. So this is nothing but a rename operation. So in total there are 7 fundamental operations, which out of which 4 of them are unary and 3 of them are binary. Which ones are binary? First is Cartesian product. The second comes is what? The second is the set difference, and the third, which is a binary, is the union operation. Okay, so 3 are binary. What are binary? Union, then the Cartesian product and set difference. So that's it. That's it for today. In the next video, I'll be covering what are the additional operations of the relational algebra and what are the extended relational algebra operations. So, in the next video,